What's up guys, and welcome to this walkthrough on the 2018 November AP Maths exam. This is the final exam, and this is the first video, but as per usual I want to start off with something that's easy, which is the mathematical proof by induction. So in this paper it is question 3, so that's where we're going to start off. So basically the question says, use mathematical induction to prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5, for n is a natural number. Okay, so for natural numbers, obviously that means n is greater than 1, greater than or equal to 1. Okay, so this is a bit different to the normal proof by inductions that we do, but once we understand what's actually happening, it's not too difficult. Okay, so the first thing that we have to do, so this is question 3. Okay, so what do we want to prove? So first we have to state what we want to prove. We want to prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5. Okay, then the second step is to prove true for n is equal to 1. Okay, so for the first value, so let's go ahead and we will say that for n equals 1, we get that let's just call this entire statement, the left hand side is equal to 3 to the 3 minus 3 to the, 2 to the 3 minus 3 to the 1, okay, which is equal to 8 minus 3, which is equal to 5. And 5 is divisible by 5, therefore proven. True for n equals 1. Okay, now what we want to do, the third step, is to assume true. So assume that the statement is true. Assume true for n equals k. Okay, so what we have is 2 to the power of 3k minus 3 to the power of k is equal to, okay, so for something to be divisible by 5, it basically means that it can be factorized by 5. So we can say that it's equal to 5 times x. Okay, and x is just a dummy variable, so it's basically for something where x is an element of the natural numbers. Okay, so x is just a dummy variable. Whatever we put into the value of x, we can, or into this entire term, must be divisible by 5, so it's 5 times some other value. So this is the statement that we assume. Okay, then step 4 is we need to prove this to be true, prove the statement to be true for n equals k plus 1. Okay, so basically what we need to do is we need to say that 3 to the power of 3 k plus 1 minus, 2 to the power of 3 k plus 1 minus 3 to the power of k plus 1. Okay, so that's what we have. So if we put this out, it's 2 to the power of 3k plus 3 minus 3 to the power of k plus 1. Okay, so now what I'm going to do is we usually try to use the assumption, what we've done here before. Okay, but instead of doing that, what I'm going to do is I can see here that we have a 3k, okay, and a 3k. So what I'm going to do is I'm going to make 3k the subject of my formula for my assumed statement. So I can say that for this statement, we can say that 3 to the power of k is equal to, 3k is equal to 2 to the power of 3k minus 5x. Okay, so then what the statement becomes is, I'm just going to write 2 to the 3 times 2 to the 3k minus 3, so that takes care of this term right there, and I'm going to insert the 3k value, so minus 3 to the power of k is equal to 2 to the 3k minus 5x, okay, and that is from here. Okay, so now what I'm going to do is I'm going to say that this is 8 times 2 to the 3k minus 3 times 2 to the 3k minus 5, or 5, or I'm going to say 3 times 5 times x, okay, and then this simplifies to 5 times 2 to the 3k minus 5 times 3x, okay, and here there is a common factor which is 5. Okay, so we can pull out the 5 and we can say that it's equal to 2 to the power of 3k minus 3x. Okay, so and this is divisible by 5. Okay, so that's clearly true. Okay, so then the last thing we need to do, or the fifth step rather, the fifth step is to make our statement. So we can say, so by the principle of mathematical induction, we have proven that, what is the original statement? 2 to the 3n, let's see, 2 to the 3n minus 3 to the n is divisible by 5. Okay, so yeah, it's a bit of a different approach. Also, just to make sure, you could, in this step, let's use a different color, in this step, we could have also said that 2 to the 3k is equal to 5x plus 3 to the k, and then done that substitution into this equation as well, and you would end up factorizing a 5 out. Okay, so it doesn't really matter which way you went about it, you could have done that too. I just decided to use 3k as the subject of my formula. Okay, yeah, so we get 14 marks there, which is about probably about 7% of the paper, so not too bad. Yeah, so thanks for watching, guys, and I hope you found this useful.